Alright, so hi everyone and welcome again to this new episode of my math videos. And for today's video, we'll be studying about the arithmetic sequence. So what do we mean by this kind of sequence? Let's say for example, you are given the sequence 1, 4, 7, 10, 13. What have you noticed to this sequence? As we can see, the sequence has a gap. So the gap is called the common difference. Notice that we get the second term 4 by adding the first term 1 by 3. And we added 4 to 3 to get 7. And we also added 7 to 3 to get 10. And this process continues depending on the number of terms. So basically, if you are tasked to locate for the, let's say, 9 terms of this sequence, you'll just have to continue listing down the following terms and locate for your desired number of terms. But how about if you are tasked to locate or to find for the 1,000 terms? It's a bit long and listing method would be difficult. So we need to find a formula in finding those higher number of term. So let's have this same sequence 1, 4, 7, 10, 13. The elements of this sequence is called first term, second term, third term, fourth term, and so on. Suppose your unknown term is called a sub n, or your n term is called a sub n. So meaning, the first term could be expressed as a sub 1, and a sub 2 for the second term, a sub 3 for the third term, and so on. So notice that the common difference of this sequence is 3. By just clearly observing or by subtracting the second term 4 to the first term 1, and we get 3. Alright, so I want you to observe the sequence and make some inferences. Notice that the a sub 1 is equal to a sub 1. And we get the a sub 2 by adding the first term or a sub 1 plus the common difference d, because we get the 4 by adding the first term 1 plus the common difference 3. The a sub 3 or the third term is arrived by adding the second term 4 to the common difference 3. So we get 7. And we also said that the a sub 2 is equal to a sub 1 plus d from the previous equation. So we can substitute that in, and we have now this new equation, a sub 3 is equal to a sub 1 plus d. And we can add the like terms d. So we have a sub 3 is equal to a sub 1 plus 2d. Moving on to the fourth term or the a sub 4, the same process, we add the third term or a sub 3 plus the common difference d. And we know that the a sub 3 is equal to a sub 1 plus 2d. So we can substitute that in. Alright, so adding the 2d's, we have a sub 4 is equal to a sub 1 plus 3d. So now, I want you to make some inferences based on this observation. What happened, or what do you observe as we try to locate for the certain number of term? For example, as we get the a sub 2, we get a sub 1 plus d. As we take a sub 3, we have a sub 1 plus 2d. As we try to look for the a sub 4, we have a sub 1 plus 3d. Alright, so what I'm trying to say is that whatever number of term you decide to look for, the a sub 1 is always present. Alright, so how about the common difference d? Notice that as you look for the a sub 2, you multiply it by the common difference by 1. As you look for the a sub 3, you multiply the common difference by 2. And as you look for the a sub 4, you multiply the common difference by 3. So what I'm trying to say is that if you will try to look for the a sub n, the a sub 1 is always present, and we just have to subtract 1 to your desired number of term and multiply to the common difference d. So we have a sub n is equal to a sub 1 plus n minus 1 times d. Alright, so this is the formula in finding a certain number of term in your arithmetic sequence. For example, find the 58th term of the sequence 3, 9, 15, 21, and so on. So solution, as we can see, the first term a sub 1 is 3, and as you try to look for the 50th term, so you have your n is equal to 50, and the common difference we have subtracting the second term 9 minus the first term 3, the common difference is 6. Formula, we have a sub n is equal to a sub 1 plus n minus 1 times d, and substituting these values, we have a sub 50, since we are looking for the 50th term, and the first term is 3 and n is 50 minus 1, and the common difference d is 6, and we have now this equation. And furthermore, we have 3 plus 49 times 6, since 50 minus 1 is 49. And for further simplification, we get a sub 50 is equal to 3 plus 294, since 49 times 6 is 294, and adding them, the a sub 50 or the 50th term is 297. Alright. Next one. Find the 2028th term of the sequence 3, 15, 27, and so on. So solution, we have the a sub 1 or the first term is 3. We are looking for the 2028th term. So n will be 2020. And the common difference subtracting the a sub 2, 15 by the a sub 1, 3, we get the common difference of 12. Alright, moving on. So the formula, and substituting the values of the formula, we have a sub 2020 is equal to the first term a sub 1 is 3 plus your n is 2020 minus 1, and the common difference is 12. For further simplification, we have 3 plus 2019 times 12. And to calculate this, we have 3 plus 24,128, since 12 times 2019 is 24,228. And to add them, we have 24,231 is your 2028 term of this sequence 3, 15, 27, and so on. Alright, so let's proceed to the next example. So we have a sequence has a 10th term of 17, and the 14th term is 29. Find the common difference. So listing down the information we have gathered, we said it says that the a sub 10 is equal to 17 and the a sub 14 is equal to 29. We can use two equations for this one by just using the formula that we have derived. Alright, so let's try first to manipulate the a sub 10. So we have it equal to a sub 1 plus, since we're looking for the a sub 10, or we're dealing with the a sub 10, we have our n is equal to 10. We have minus 1 times d, since we don't know the first term and the common difference d. But we know the a sub 10 is equal to 17. So we have a sub 1 is equal to 90, and then we can transpose the 90 to the left side, and we can have the equation for a sub 1, 17 minus 9d. Alright, so stop right there first and go over to your next equation. Now let's manipulate for the a sub 14 with the same process. We have, since we are dealing with the a sub 14, so the n is 14. So continuously, we have a sub 14 is 29. So substituting that in is equal to a sub 1 plus 13d, since we don't know yet the common difference d and the a sub 1. Now, transposing again the 13d to the other side, we get 29 minus 13d equals to a sub 1. So notice that we have now two equations for a sub 1. So we can equate them since they are equal. So we can equate the two equations. 17 minus 9d is equal to 29 minus 13d. Solving for d for this equation, we have this. Transposing the 13d to the left side, we have negative 9d, and then it will become positive 13d is equal to 29. Transposing the 17 to the other side, it will become negative 17. And we have 4d is equal to 12. And dividing both sides by 4, we get the common difference of 3 in this sequence. Thus, the common difference of this sequence is 3. Alright, let's move to our last example. So it says that the first, second, and the nth term of the sequence are 2, 6, 58 respectively. Find the value of n. Alright, so we have listing down the information we have gathered from the problem. It says that the a sub 1 is equal to 2, and the a sub 2 is equal to 6, and the nth term a sub n is equal to 58. And we don't know how many number of terms. Alright, so that's what we are looking for, the value of n. So notice that we are given the first and the second term. So we can get the common difference by subtracting the a sub 2 by a sub 1, and we get 6 minus 2 equals to 4. The common difference is 4. Now, applying the formula, we have a sub n is equal to a sub 1 plus n minus 1 times d, and we know that the a sub 1 is 2, and we also know that the a sub n is equal to 58. So substituting those information, we have 58 is equal to 2 plus, we don't know the n yet, so we have n minus 1, and the common difference is 4. So we have now 58 equals to 2 plus, distributing the 4 inside, we get 4n minus 4. And furthermore, we have 58 is equal to 4n, and 2 minus 4 is equal to negative 2. And we have to transpose that negative 2 to the left side. We get 58 plus 2 equals to 4n, or 60 equals to 4n. And dividing both sides by 4, we get the value of n is 15. Alright, so we have solved for the value of n. So, a quick recap. The formula for this equation is a sub n is equal to a sub 1 plus the quantity of n minus 1 times t. You'll just have to identify the a sub 1, the a sub n, the common difference, and manipulate them applying the formula. So I hope that you have learned something about this video. And if you don't solve, please try to solve this problem, and please show your solutions and answers to the comment sections. So that would be all. Thank you, and once again, this is John Artejones. Thank you.